Hi everyone, and welcome back to educator.com. In this mini lesson, we're going to do page 1 of the A+ Physics worksheet on the electromagnetic spectrum. You can find a link to that worksheet down below. Now to do this, I would highly recommend you have a copy of the electromagnetic spectrum in front of you, somewhere where you can refer to that in order to answer these problems, because they could be pretty tricky if you don't have that in front of you to answer the questions with. So let's dive into number 1. Compared to the speed of a sound wave in air, the speed of a radio wave in air is, well, that's going to be much greater. Radio wave is an EM wave. It's going to travel at 3 times 10 to the 8th meters per second. Number 2, an electromagnetic AM band radio wave could have a wavelength of, well, to answer this, I've got to go look at my electromagnetic spectrum. AM band radio waves I find in the range of somewhere about 100 to 1,000 meters for their wavelength. So the correct answer here would be 3. Number 3. What color of light has a wavelength of 5 times 10 to the minus 7 meters in air? Well, the first thing I'm going to do is I'm going to find the frequency. That helps me determine what type of wave it is. So if V equals F lambda, then frequency is V over lambda, which is going to be 3 times 10 to the 8th meters per second over 5 times 10 to the minus 7 meters, which is going to come out to be right around 6 times 10 to the 14th hertz. Now I go look for that frequency on my electromagnetic spectrum, and I find that that's just at the border of blue and green, but slightly into green on my version of the spectrum. So we're going to call that green. Number 4. In a vacuum, all electromagnetic waves have the same speed. That's that constant c, the speed of light or electromagnetic waves in a vacuum. Number 5. An electromagnetic wave traveling through a vacuum has a wavelength of 1.5 times 10 to the minus 1st meter. What's the period of this electromagnetic wave? Well, to find the period, I think the first thing I'm going to do is realize that period is 1 over frequency. So if I use V equals F lambda, well, frequency is 1 over T, so V equals lambda divided by the period. Therefore, the period is going to be the wavelength over the velocity, which implies then that the period is our wavelength, 1.5 times 10 to the minus 1 meter, over the velocity of our wave, 3 times 10 to the 8th meters per second, because it's traveling in a vacuum, and I'm going to come up with the period of about 5 times 10 to the minus 10 seconds. Answer number 1. Number 6. Which characteristic is the same for every color of light in a vacuum? Well, obviously the answer to that must be speed. All electromagnetic waves have the same speed in a vacuum, 3 times 10 to the 8th meters per second. Number 7. Exposure to ultraviolet radiation can damage skin. Exposure to visible light does not damage skin. State one possible reason for this. Well, one reason that I can think of right away is that UV radiation has a higher amount of energy. It has a higher frequency, therefore more energy, more ability to do damage. So I would say that UV has a higher frequency, therefore a higher energy. All right, moving on to number 8. An FM radio station broadcasts its signal at a frequency of 9.15 times 10 raised to the 7th hertz. Determine the wavelength of this signal in air. Well, if V equals F lambda, then our wavelength, lambda, equals velocity over frequency, which is 3 times 10 to the 8th meters per second, because it's in air, divided by our frequency, 9.15 times 10 to the 7th hertz, is going to give me a wavelength of right around 3.28 meters. All right, number 9. Sunlight is composed of various intensities of all frequencies of visible light. The graph represents the relationship between light intensity on the y-axis and frequency on the x. Based on the graph, which color of visible light has the lowest intensity? Well, that's going to be over here, where we have the highest frequency. And the highest frequency of light is violet. Check that out on your electromagnetic spectrum. So which color of visible light has the lowest intensity? violet. Number 10. Sunlight is composed of various intensities, same graph we've had before. It's been suggested that fire trucks be painted yellow-green instead of red. Use information from the graph, explain the advantage of using yellow-green paint. Well, yellow-green paint is here toward the middle of the spectrum where we have the higher intensity. So in that case, you're going to have a greater intensity of incoming light to reflect off the fire truck, so hopefully the people pick up more intensity from their eyes. You have more intensity of light getting to people's eyes. So I would write something like, you have a greater intensity for reflection at approximately, well, in the green. How's that? In the green. All right, two more. Which wave characteristic is the same for all types of electromagnetic radiation traveling in a vacuum? We've seen this before. Hopefully you're picking up a trend that the answer there must be 1 speed. All right, last question. Calculate the wavelength in a vacuum of a radio wave having a frequency of 2.2 times 10 to the 6th hertz. Well, we'll use our wave equation, V equals F lambda, and we're looking for wavelength, so that will be velocity divided by frequency, or 3 times 10 to the 8th meters per second, divided by our frequency of 2.2 times 10 to the 6th hertz, should give us a wavelength of right around 136 meters. All right, that concludes page 1 of the worksheet on electromagnetic spectrum. If that went well, terrific, go ahead and move on. If that didn't go so well, now would be a great time to go back and review that portion of the lecture course. Thanks so much for your time, everyone, and make it a great day.